Hi all, welcome to this session of disk scheduling. Till this time we were discussing about the primary memory and the processors. Now we will go to disk management, which is one of the main responsibilities of the operating system. As we all know, in modern computers, hard disk is used as the main secondary storage device. We have to quickly refresh the structure of a hard disk. Hard disk is a collection of platters, and each platter has a circular shape. A read or write head is located above the surface of every platter, and the surface of the platter is logically divided into circular tracks. Okay, it is divided into circular tracks, and the tracks are further subdivided into sectors, and the set of tracks that are at one arm position forms a cylinder. The heads are attached to disk arm with all the heads as a unit. The storage capacity of a common disk drive is measured in gigabytes. And next, I'll tell an important term which is known as the seek time. It is the time taken to position the head at the desired track. And normally when we are calculating the disk, we are doing using the disk scheduling algorithms, we will be calculating the seek time, which is the time to position the head at the desired track. Then we will move to disk scheduling algorithm. As we all know, whenever a process needs input output to or from the disk, it issues a system call to the operating system, and if the drivers are available, the request is serviced immediately, and if the disk device controller is busy, then it will be kept in a queue. And we know that in a multi-programming system with many processes, when one request is completed, the operating system chooses which pending request to service the next from the queue, and the system has to make a choice based on any one of the several disk scheduling algorithms. And the main responsibility of the disk scheduling algorithms is to schedule the order of disk IOs to improve performance. There are mainly a lot of disk scheduling algorithms available, and out of which we will be learning four algorithms: FCFS scheduling algorithm, SSTF or shortest seek time first scheduling algorithm, then scan scheduling, and C-scan or circular scan algorithm. So first we'll have a look into the first come first served FCFS scheduling. As we had seen in the case of process scheduling, this is the simplest scheduling algorithm of all, which process the jobs based on the first come basis. So here, as I said, the head starts at one position and it is moving forward or backward or in any order based on the scheduling. So first, if we have for the illustration of this example, we are taking an example with this queue as 98, 183, 37, 122, 14, 124, 65 and 67. And the disk head is initially at position 53. And how it is moving, that we will see. So it starts from the position 53. In FCFS scheduling, what happens is first job is 98. First head to move is to 98. So it is moving from 53 to 98, which is at a distance of 45 apart. How we are calculating 45? It is 98 minus 53. So now the head is at 98. The next position to reach is 183. So it is moving to 183, which is at a distance of 85 apart. So once it is reaching 183, the next head to reach is 37. So it is moving back all the distance from 183 to 37. And then next to reach is 122. Then next to reach is 14. And next to reach is 124. Then next one is 65. And then next to reach is 67. So it finishes all the head movements. It finishes all the movements and come to an end at the last position of 67, which is processed in a first come first served fashion. So this algorithm is not perfect. As we can see, the wild movement from 122 to 14 and again from 14 to 124. If there was an algorithm which processes in 122 to 124, the cylinder movements will be less and we can make it in a faster number of movements can be reduced. So on calculation of this movements, we can come to a conclusion that it moves up to 640 cylinders. You can calculate and see that is the movements will be 45 plus 85 plus 146 plus 85 plus 108 plus 110 plus 59 plus 2, which will be a total head movement of 640 cylinders. And the better algorithms will be having lesser head movements, and we can go for another algorithms. And the next algorithm we have to look is shortest seek time first, SSTF scheduling. We will see the strategy of shortest seek time first scheduling. So in this scheduling, it selects the request with the minimum seek time from the current head position. So it is another format of shortest job first, where we can see that the nearest job, the shortest jobs from the initial head position will be processed first. So first we will have a look at this. We have to start, the head starts at position 53 and the nearest position from 53 is, or the shortest movement from 53 is to 65. So it takes only 12 movements. So it is going to 65 and we can next go to a place where the shortest one, 65 to the shortest will be 67. And when we are considering 67, next shortest span will be for 37. And similarly it is going from 37, the nearest one will be 14. And once it reaches 14, the next nearest one will be 98. And the next nearest one will be 122. And the next nearest one will be 124. So here we can see that 122 to 124, it is moving only two movements, two cylinder movements are there. But in the previous example, we had seen that in order to process for the first come first serve, there was a wild movement from 122 to 14 and again from 14 back to 124. But here it is directly moving from 122 to 124, reducing the seek time. Then from 124 to 183 it is reaching, and finally it has come to the end of all the movements and the head rests at the position 183. So on calculation we can see that there is only a total head movement of 236 cylinders. In the previous case it was 640 cylinders. Now it's only 236. The next algorithm in this series is scan scheduling algorithm. This is also known as elevator algorithm, and how this is processing. The arm starts at one end of the disk and moves towards the other end, and it services all the requests till it reaches towards the other end. We will see how it's working with our previous example, where we have the disk which has 200 cylinders numbered from 0 to 199, and the head starts at 53. So initially it starts from 53 and it starts at one end of the disk and moves towards the other end. We can see that it starts from 53, it moves towards the other end. Here we need to reach up to 14 only, but in this type of algorithm it is moving up to 0 towards the other end, and then it moves towards the next end by processing all the jobs in between, all the movement, all the heads in between. So here first it starts from 53, the next nearest one is 37, then to 14, then to 0, it reaches the end. That is important. It can either move in the other direction also, it can start in the other direction also, but in this example we are showing like this only. Then from 0 to 65, 65 to 67, and then towards 98, then towards 122, 124, and finally it reaches the reaches at 183. And what will be the total disk movements in this case? And you can calculate and see the total disk movements in this case comes around 208 cylinders. And if requests are uniformly dense, largest density at other end of the disk, and the others needs to wait for the longest time. That will be a difficulty of this algorithm. And then next algorithm of this similar pattern is C-scan scheduling, which is also known as circular scan scheduling algorithm. We have seen that the main drawback in scan scheduling is the waiting time is not uniform. Some requests are waiting much time and some requests are servicing immediately. So we can overcome this drawback with the circular scan scheduling algorithm, which is designed to provide a more uniform wait time. So here the algorithm moves the head from one end to other end of the disk, servicing all the requests along the way, and when the head reaches the other end, it immediately returns back to the beginning. So we will see how it's working. So it services all requests from one end to the other end, and when it reaches one end, it immediately goes back from the one end to the other end. That is it. We had seen that the disk has 200 cylinders and it is numbered from 0 to 199. So in FCFS algorithm and SSTF algorithm, it was not moving from 0 to 199. The only requested numbers will be processed. But here it is reaching one end and it is reaching back all the way to the other end. That is in order to make the wait time uniform. In the previous example, we had seen that it is reaching one end, but it is not reaching towards the other end. It is processing in other fashion, and this is we will see how it's working. So it's taking from 53 to 65, 65 to 67, then to 98, then to 122, then to 124, 183 was our request, but it will move all the way to towards the end 199, and it will move all the way towards 0, then to 14, and then to 37. That is, it is following a circular fashion and makes the wait time uniform. So let's calculate the total head movements. Let's calculate the total head movements. What will be the total number of heads? You calculate and see what will be the total head movements. Then this treats the cylinders as a circular list. This is the advantage of the algorithm. We had seen 4 algorithms, and now we will see how we can choose a disk scheduling algorithm. from all the list of 4 algorithms, SSTF is common. It is very simple and it has a natural appeal. And most commonly used algorithms are scan and C-scan algorithms, and C-scan perform better for systems that place a heavy load on the disk. And the disk scheduling algorithm should be written as separate module of the operating system, allowing it to be replaced with different algorithms if necessary. So thus we have come to the end of disk scheduling or disk I/O, which is one of the main responsibilities of the operating system.